and today's topic is homeostasis, how the body is balanced. So let's get started. Homeostasis, what does that even mean? So homeo means similar, stasis, stable or stand still. So homeostasis is how to keep the body's internal environment constant. So how does your body work? You have the good stuff such as nutrients, the bad stuff, the waste products and carbon dioxide, and you need communication system. So how to get the good stuff? To get nutrients you need to eat. This is the gastrointestinal tract. To breathe you need the respiratory system to get oxygen. Okay, now how to give the food and oxygen to every single cell in your body? You need the circulatory system or cardiovascular system, also known as CVS. Not the pharmacy, okay? Then we have the bad stuff, the waste products, the liver and the kidney.
Homeostasis is maintenance of a constant internal state in a changing environment. It is a desirable state of equilibrium. In order to help you understand homeostasis, let's take a look at a couple of examples. Healthy individuals maintain a temperature around 98.6 degrees Fahrenheit. If it is hot outside, your body cools itself, and if it's cold outside, it will still maintain this temperature. If it's not able to maintain this internal temperature of 98.6, or roughly thereabouts, bad things can happen. A healthy blood pressure is another example. Your body likes to maintain a blood pressure in a certain range. Your heart, brain, circulatory system, and endocrine system are all working together to maintain a healthy blood pressure. Maintaining the correct balance of water is vital for your body. Your kidneys constantly monitor your water balance and makes adjustments.
So here we have a human, and our internal temperature, our internal environment temperature, the healthy human temperature is 98.6 degrees Fahrenheit. It's something else, Celsius, but Fahrenheit, because we're in America. So if you get above 99, then they say that you have a fever. And the farther above 99, then the worse off that you are. So the first thing that you typically will do when you start to have a body temperature above what it should be is you're going to start sweating. And sweating, as a lot of people think, ew, it's gross, it's nasty, you don't want to sweat, blah, blah, blah. Sweating is your body's way of cooling itself off, because when that sweat evaporates, it takes the heat energy with it and cools your body. Sweating doesn't actually help you if you wipe your sweat off. You have to let it evaporate. So if you're overheating and sweating, your better bet is just go stand in front of a fan so that fan can help that sweat evaporate, and it will help cool your body. Now, if you get below 98 degrees Fahrenheit, also not a good thing. The first thing that happens is that you start getting goosebumps. Goosebumps go back to the day when we were really furry, because all of the hair on our body would stand up and trap the heat in between all of that hair and help to create this warm layer of air around our body. If goosebumps doesn't work enough, you usually start shivering. And shivering takes the energy that's stored in your muscles and starts turning that into heat energy with those little twitchy things that your muscles do. And it's your body trying to return to its normal temperature, its normal internal state. Now, if you remain in an environment with an extremely high or extremely low temperature, over time,
the negative feedback loop will cause the body to shiver, producing heat, and ultimately body temperature will return to within the set point range. The negative feedback loop will do the same if body temperature increases, like during exercise. The negative feedback loop will cause the body to sweat, which will reduce body temperature to within the set point range. Positive feedback control loops do not help the body maintain a stable homeostatic condition. Positive feedback control loops amplify the change that is happening to the body. So let's say that someone has a bacterial infection. The immune system signals the brain to increase the body's temperature set point, causing a person to have a fever. This can be a natural, normal reaction. However, in some instances, it could create a harmful positive feedback loop where metabolic rate is elevated and the body is producing heat faster than it can get rid of. So a person may be shivering and sweating at the same time.
Hey, you gotta measure, hey, all the levels in your body with the sensor. Hey, if it's too high, back to baseline. Hey, if it's too low, raise it up, that's fine. Hey, so when you go exercise, need the pressure to rise. Raise the set point up, your heart increases in time. Constrict your vessels, that increases the pressure until you're done exercising back to original levels. Temperature, blood sugar, go, go, go. Blood to face, acid base, carbon waste, H2O.